Okay, so we're going to have the next talk still on SITELLE, but moving from local universe to some bright galaxies in galaxy clusters. So it's a different view with SITELLE. And the presenter is, I hope I pronounced it correctly, Marie-Laure Gendron-Marsolais.
Yeah.
Okay. Also from University of Laval. Yes,
Thank you. That's always a challenge. This very long name. So hello, everyone. It's my turn. I'm so happy. I want to start my presentation by showing you this beautiful image with Euclid of the Perseus cluster. We have seen this image a few times, I think, in the last few days already. But this is my favorite galaxy cluster, so I really wanted to show this image again. The Perseus cluster is a very nearby and bright galaxy cluster. It has been very well studied. It is at the center of many important discoveries in my field. But first, I want to start by actually confessing something to you guys. I'm actually a radio astronomer, okay? I know, shocking. Okay, so what am I doing here? Actually, what I do is I study galaxy cluster, but I study mainly synchrotron emission in galaxy clusters. So these relativistic particles that diffuse in these complex environment. This is a low-FAR observation of the Perseus cluster. You see these amazing structures. But one day during my PhD, I met Laurent Sen and I found out about SITELLE, and it really changed my career. So I'm going to tell you a little bit more about that during my talk. This is all centered on this main galaxy inside the Perseus cluster, NGC 1275. But I want to start by some context first on galaxy cluster. So AGN feedback is regulating galaxy cluster. This is what we know now. So you have the supermassive black hole. So I am interested in supermassive black hole. These are cool objects. So they release these very powerful relativistic jets that heat the intracluster medium. They make these cavities, these bubbles that rise inside the cluster. They mechanically eat the intracluster medium. And then so this is how we have this prevent the intracluster medium from cooling. Of course, this loop has to be closed somehow. And so we have these kind of precipitation models where, so the gas in this atmosphere is at some point, probably due to thermal instabilities, condensing into colder filaments, which eventually will feed the supermassive black hole. So this is closing the feedback loop. Okay, so this is what we think is happening inside galaxy cluster. Do we have traces of that? Do we see this? Actually, yes, in the warm phase especially. So we have those filamentary emission line nebula surrounding many brightest cluster galaxy. Actually, in almost all galaxy cluster like Perseus, we have those kind of filaments. They are very extended, very thin. Sometimes they are quite bright as well. And so these are key for us to understand this AGN feedback loop. Of course, you can imagine that IFU observation have been very important for us to understand these kind of filaments. These are few MUSE observation of these filaments. So MUSE has been observing several brightest cluster galaxy, revealing perturbed kinematics inside those filaments. But as you can see, in many cases, the most nearby cases, especially in the most extended cases, MUSE is actually not big enough to encompass all of these filaments. Yeah, this is what I just said. So going back to Perseus, during my PhD, so I started my PhD in 2014. At that time, SITELLE had just been put on CFHT, taking the first data. And I was studying the Perseus cluster with the VLA, so studying the synchrotron mission, right? And it is during a user meeting, but of the Observatoire du Mont Mégantic, or telescope here, that I met Laurent Sen, and he was talking about SITELLE, of course, and he told me that there was a cube of science verification data that had been taken of NGC 1275, the brightest cluster galaxy of this cluster. So back in the days, I knew that there was some weird filaments around this galaxy, but not much more. But when I saw these data, I was like, okay, we have to work on that. So studying galaxy cluster with SITELLE is actually something really nice. I'm going to show you several results that we have obtained with that. But I also want to highlight these kind of studies that people do for higher redshift galaxy cluster as well. So of course, the filling factor is not as impressive as a signals survey or supernova remnant or this kind of things, but we can still do a lot of great science. We, with the help of Thomas Martin, we fitted those data and we obtained those maps. I think you saw them also yesterday in the talk of Benjamin. He presented the higher spectral resolution maps, but this was the first time we had the full velocity map, right, of this galaxy. CFHT made a really nice press release about that, so thank you. And I was looking now, when I published this was in 2018, and this paper now has over 45 citations. Since then, we accumulated more SITELLE observation of NGC 1275. I just mentioned Benjamin's work at very high spectral resolution. We had also SITELLE observation in the other filters with SITELLE. And this is the typical spectrum of those filaments. And the spectrum of those filaments is actually really weird. There's a lack of O3 emission, and the N2 over H alpha ratio is quite high. And we see this in NGC 1275, but in many of those filaments around BCG. So they have strange spectrum, but now with SITELLE we confirm this over the whole filaments. We only found some O3 emission in the very, very center. So this is the BPT diagram that we reconstructed from just the very center. This is the full N2 over H alpha map where you can see the radial gradient. And so how do you explain the spectrum is very complex and is still a very hot topic of investigation, actually. So yesterday, Benjamin was asked like how these filaments are ionized. It's not a simple question. So it's probably a combination of many things. And this is just a few ideas of people that have been thinking about that over many, many years. Oh, there is two filaments that are really interesting in NGC 1275. These two here. Okay, this is the galaxy, but like on the side. And there is this cavity, right? These jets, like they inflate cavities inside the intracluster medium. And you have these two filaments that are just trailing behind these cavities. So it really looks visually like like a bubble that is rising, and you have like some entrained material behind. Does it work? Is it really the case? Well, we now have simulation that we can compare to our velocity maps, and it looks like indeed these bubbles, okay, that are rising are really having an impact on the kinematics of those filaments. One thing that we could do also with our velocity maps is compare with, for example, the C2 Herschel map here. So you're comparing different phases together to see if this model is actually working. And there is like a really big, really good match in between the kinematics of both of these phases. They are really co-moving, which show that this model is working. We also show that it's the case for the molecular gas, but only in the center, that we have only in the center of the galaxy. Can we do the same and compare with the hot plasma? It's much more difficult, right, to resolve the emission line in X-rays, but with microcalorimeters now we can do this. And Hitomi, during its very short life, had the time to observe the Perseus cluster. You can see here in the background Chandra observation with all the cavities inside the cluster. And this is an actual velocity map of the intracluster medium, the only that we had from Hitomi. We can compare this with SITELLE, of course, very different spatial resolution. But what is interesting here is to compare the velocity dispersion, which are very similar. So Hitomi found that despite all this activity of AGN feedback, the intracluster medium is moving in a has kind of very mild motions, like what we find inside the filaments. This is what we could do for a few years, but now we have CRISM. I don't know if you've heard of that super nice mission it's taking. The results are now being published, very interesting papers over many different galaxy clusters. So it's going to be very interesting to compare, for example, SITELLE with CRISM. And I think Benjamin is working on that, so that's going to be really nice. Another work that one of my collaborators, Valeria Olivares, did A few months ago, we published this paper, so she was able for the first time to isolate the X-ray emission from these filaments. So before, they were all mixed together inside the intracluster medium, which is very bright, but she was able to isolate them and compare to the H-alpha emission that we had from SITELLE. She did this for Perseus, but also for 6 others galaxy cluster, and she found this correlation between the X-ray surface brightness and the H-alpha surface brightness. So again, another clue that this precipitation model is probably right. And we had this nice press release, which title is a bit strange, but anyway. So one last thing that we did as well, this is work by my collaborator, Yuan Li. She studied velocity structure function based on our velocity map. So velocity structure function are correlation between separation of pixel pairs and their average absolute value in their velocity differences. So we get these kind of slopes here. And what we conclude from that is that based on the slope that we have here, we can say that the gas inside these filaments is quite turbulent. And this is what also we see in the kinematic maps there. It's quite chaotic, let's say. But there's a flattening here that happens at a scale of about 10 kiloparsec, which is also the size of these cavities, okay? We found this for Perseus, but she looked at many other clusters, and we often have this, well, in all of these cases, we always have these kind of similar shapes. So it looks like the supermassive black hole, which is doing those cavities, is the main driver of the motions inside the galaxy centers. So a really nice analysis. I've been talking about NGC 275, but there's actually another really interesting nearby brightest cluster galaxy, M87, which I learned yesterday is supermassive black hole, is called Poveci. That's super nice. And actually, if you remove the stellar continuum from this galaxy, this is what was done with Vestige, actually. They found this very nice network of filaments, and some of these filaments are actually completely detached from the main nebula. And we have SITELLE observation of this galaxy, and this is work by my master student, Camille, who's working on that. She even have a poster about that, so if you're interested, you should go see her. This is just to show you the velocity map that we obtained of the full filament. So gives you an idea of the power of SITELLE. Okay, so I was supposed to be only a radio astronomer, but then I found out about SITELLE, and it really changed my career, and I'm really thankful to have the opportunity to work on those data. So thank you.
Any questions from Marie-Rose?
Hi. So I was yesterday very much impressed by the eventual presence of polarization in those lines in this kind of objects. So have you found or have you observed for any polarization here?
Well, maybe. Yeah. With the Espadon data, we will.
Yeah, but that was your object, and now I see new ones.
It's the same galaxy.
Okay, yeah. So
maybe. But actually,
maybe you need a new twitch in your career.
Or Benjamin's career, that would be nice. But actually, one point about that, there is this paper. Well, it dates a little bit, but this is a close up of these filaments. This is the 2 filaments I was telling you about that are like trailing like this. And this is HST observation. They are really, really thin, these filaments. And they are embedded in this super hot intracluster medium, right? So there are people that have been suggesting that you really need magnetic field or something like that to hold on these thin filaments together. So maybe.
As I was saying, Benjamin, is that right?
Yeah.
Later, it's not only magnetic fields that may be accessible through polarization. If it is linear polarization, we may have access to densities and radiation process, but
interesting avenue. Yeah.
Any other question? If not, let's thank our speaker again.